Hello friends, welcome back to the water tank automation playlist. This is fourth video in the playlist. In the previous video, we have seen how to build this motor controller module, and also we have configured this motor controller module to control via HTTP post request. And also I have printed this cute 3D printed case for this module. So this module goes behind the switchboard. Okay, let's keep the motor controller into the case. Okay. So this is how the 3D printed case looks. So we have a slot for inserting the node MCU, and also we have slot for inserting the wires. And if you want to tighten the screws, you can do it from the top slot. And this whole module will go behind your switchboard. So this case will helps you to isolate this from any other live wires in the switchboard. Okay, let's keep this aside. Let's talk about the float switch. So float switch is a very easy mechanism. It contains a metal ball. Basically, the metal ball is moves freely in the float switch. So if I move float switch like this, I can feel the metal ball. So what that will do is when the float switch hangs vertically upward, that means water in the tank is full. So then it will create a connectivity between black and blue wire, because the ball is at bottom position, and this is where we have terminals, and the ball sits between those terminals. That creates a continuity between blue and black wire. In the same way, if there is no water in the tank, the ball will go to the other side of the sensor. So then there won't be a continuity between black and blue wire. Okay, so basically this is a simple switch that creates continuity between the wires. And also along with these two wires, we have one more wire that works exactly opposite to the blue wire. So when there is connection between black and blue, there won't be any connection between black and brown, and vice versa. So we are not going to use this brown wire. We are only using this black and blue wire. And also like we need two sensors. Okay, so because we want to clearly sense two positions. One is when the water is full and the water is low. So there are two positions in the tank. That's where we want to decide whether to start the motor or stop the motor. Okay, let's talk about the module at the water tank side. So the basic functionality of this module is read the sensor data and decide whether to turn on the motor or not. It will send a HTTP post request to motor controller module to turn on the motor or not. So we have the Highlinks power block here, which converts AC to DC. And this particular module will take the AC and generates 3.3 volt DC, because ESP01S directly requires 3.3. It cannot tolerate 5 volts, which is different from other module. So this other module also contains Highlinks power supply. So this module is 5 volts output. But in this case, we are not providing 5 volts directly to ESP01S in this module. Instead, we give 5 volts to relay module, and relay module contains the voltage regulator. Then that voltage regulator will convert 5 volt to 3.3. Okay, so this is a different scenario than the module at the water tank side. Okay, let's talk about circuitry at water sensor side. So the power supply part is common between water sensor and as well as motor controller units. So you will give AC power supply to Highlink AC to DC converter, and that will give you DC output. The only difference is at motor controller, you will get 5 volts. In water sensor side, you will get 3 volts output, because at motor controller, we have that voltage regulator in the relay, but we don't have any voltage regulator. We need to directly connect this 3.3 volt to VCC of your ESP01S at a water sensor side. And also we have this CHPD pin which need to be sorted with the VCC. At the motor controller side, this is happened internally inside the relay unit itself. So as we don't have relay unit at water sensor side, we need to manually contact CHPD with VCC. And your ground from the DC output will go into the ground of ESP01S. We have two sensors. bottom float switch and top float switch. And we have four GPIO pins which you can use for these sensors. Okay, so the GPIO 1, 2, and 0 and 3. These are the four GPIO pins. But GPIO 1 is connected to TX and GPIO 3 is connected to RX. So these TX and RX pins are mainly used for UART communication. So by default, this UART communication is turned on in the ESPHome. So we need to turn off this UART communication in ESPHome to use these TX and RX pins. We will go to the coding part of it or configuring part of it later. You will connect one side of your float switch to the TX and other side of the float switch to the ground. Okay, so in the same way, the second float switch also connected to GPIO2 and ground. The TX and GPIO2 both are configured as input to the ESP01S. As we discussed earlier, when there is no water at the float switch position, the float switch freely hangs, it won't float. When it is freely hanging, then there would be a continuity between both the wires in the float switch. When there is continuity, we call it on position, right? If we consider float switch as a switch, the switch will be in the connected position. If you see here, the switch is currently in the disconnected position. That means the water is full at that particular float switch position, and float switch is basically hanging on top of water. Okay. So here also the same situation. So if you see, both the top float switch and bottom float switch are open condition, that means both the float switch are floating on the water. Now, when the float switch is in open position, both GPIO 1 and GPIO 2 are not connected to ground. So if the bottom float switch and the top float switch are closed, that means no water in the tank. Basically, both the TX and GPIO 2 is connected to the ground. So if you observe, in the open position, both the pins are not connected to anything, and in closed position we are connecting to the ground. We can detect that particular float switch is closed because we are getting the ground, but when it is open, we are not getting anything. We are not getting either ground or we are not getting 5 volts. It's just open. It's just freely floating in the air, right? So this is called a floating GPIO pin. So the floating GPIO pin is always a problem. So, right, when a GPIO pin is not connected to anything and you're trying to measure the input in the GPIO pin is high or low, it can give some random value. Sometimes it will give high, sometimes it will give low because it's not connected to either high or either low. Okay, so we need to resolve this. So we need to update this circuit a little bit. So this update, you don't require to do it in the actual circuit. You just need to define something on the code. There will be a small circuit formed internally at these pins. So just for the representation purpose, I am bringing that internal circuit outside. We will see how that looks. Okay, we need to define something called internal pull-up resistor. So we need to define it on both GPIO 1 and GPIO 2. So what this internal pull-up resistor will do is it will internally activates a pull-up resistance between your pin and positive 3 volts. So since the float switch is in on position, there is no other path. TX will be connected to 3 volts. So then when we take the input on TX, it will be shown as high. So when the float switch is off position, the TX is connected to both 3 volts as well as the ground, right? But if you see the to the ground, TX is directly connected, right? But to the 3 volts, it is connected through a resistance. Okay, so we already know that electrons will always flow through a least resistance path. So here our least resistance path is the ground. So that's way when you take input on TX now, when the float switch is closed position, you will detect low. We removed the confusion or basically the floating pin by allowing a internal pull-up resistance. Okay, so there is one more issue with this circuit. To understand that issue, you need to understand the boot sequence in ESP01S. So ESP01S has two different boot modes. One is normal mode, one is flash mode. So in normal mode, ESP01S will run whatever code present in it. In flash mode, it basically goes into a programming mode. That's where you dump your program. When you turned on ESP01S, you want it to be running in normal state to run the code, right? Let's say if ESP01S is turned on, either GPIO 0 or GPIO 2 is connected to ground, then that's where the problem arises. Then ESP01 will go into the flash mode. It won't boot as a normal mode. So you don't want your GPIO2 or GPIO0 connected to ground when you are starting ESP01S. Okay, so let's take this scenario. A scenario where the water in the tank is completed. Okay, so there is no power from last 1 day or something, and there is no water in the tank. So that is your scenario. So both the float switches are in closed position. That means your GPIO2 is basically connected to ground. Okay, then suddenly power comes. Now, since your GPIO2 is connected to ground, your ESP01S will boot into flash mode. It won't go into normal mode. If your ESP01S is in flash mode, it won't run anything related to ESP home automation. So it won't turn on the motor, it won't send any water into the tank. And this is never ending loop, right? And this is a very big problem. So having GPIO2 connected to ground when ESP01 is booting is the problem, right? So somehow we need to change this to something other than ground when it's booting. And once the boot is successful, we can change this back to ground. So we need a changing source. How we can generate a changing source? Yeah. So let me tell you. Directly, we are connecting both the sensors output to the ground. Don't do that. Instead, we connect both the sensors output to some other GPIO pin. Okay, so what GPIO pin we have? So we have GPIO 0 or GPIO 3, right? So GPIO 3 also causes some issues. I don't want to go into them, but GPIO 0 is perfect for this use case. So instead of connecting your other end of your float switch to the ground, connect this other end to GPIO 0. So when ESP01S is booting, GPIO 0 by default writes a high output. That means 3.3 volts. Now we are removing this ground and connecting the other end of the float switch to GPIO 0. When the float switch is closed position, we will get high voltage at GPIO 2. So at the booting stage, ESP01S GPIO 0 will write high output, and that output will go into GPIO 2. And when GPIO 2 is high and GPIO 0 is high, the boot will happen normally. There won't be any problem in the boot. But for our circuit to work properly, we need to have a low state for both GPIO 1 and GPIO 2 after the boot. So how we can control it? So GPIO 0, once we are booted into firmware, we can write back a low state into GPIO 0, right? Then GPIO 0 will act as ground. So when we are booting, GPIO 0 will act as a 3.3 volts, and after the boot, we can make this GPIO 0 as ground. So this is how we solve the issue. Okay, this is how your final circuit looks like. So you will connect the positive of high links module to VCC and CHPD and a ground to ground. Okay, and you will connect one side of your high links module to AC source. Then you will connect TX, that is GPIO01, to one end of the float switch and other end goes into GPIO0. In the same way, one end of second float switch will go to GPIO2 and the other end go to GPIO0. So this is your final connections will look like. Okay, let's program ESP01S with the ESP home device builder. Okay, to program this particular ESP01S, let me remove this. Okay, I'm connecting this ESP01S to the ESP01S programmer, and let me insert this programmer into the system. Open the ESP device builder. So let me create a new device. Let's click on new device and click on continue. I'm calling this as a tank water sensor. Next, and I'm choosing ESP8266 and click on install. So here we need to go to manual download. Bin file is downloaded. Let's dump that bin file. So let's click on connect, and this is the water sensor module. Install select the bin file. Yep. Okay, so the device showing offline even after installing the firmware. So we need to set up a static IP to make this online. So let's do that. I already did the static IP assignment in the router to this water tank sensor controller. So let's edit. Okay. So I assign this particular IP address in the router for this particular device. I have explained in detail in previous video how to set up static IP in the router. Okay. Let's also enable a web server on this device so that we can able to see what's happening, the logging and all. So let's enable this too. This should be the 11. Let's go ahead and click on save and now install wirelessly since the device is already connected on the IP. Dumping the firmware wirelessly, I can see my water tank sensor came online. Let's remove the ESP01S from programmer and put it in water sensor module. So now both the modules I have given AC power supply. Also, if you see, I have connected both the sensors, water sensors to the module. Let's power on the both the modules. I have power supply plug here. I'm connecting it. Now, if you see both the modules are powered on, let's see if they come online in the dashboard. Both the modules online. So basically, my motor controller is running at 192.168.0.10 and water sensor module is running at 0.11. Okay, so let's see the logic for the water sensor. Okay, let's go through the logic now. So a lot of things are default. I will talk about the things which we need to change. Okay, for both the sensors, you need to create two binary sensors. So I have one binary sensor that is a top float switch and second binary sensor bottom float switch. If you see, both of them has input pull up register enabled to them, and one sensor is connected to GPIO2 and second is GPIO1. GPIO1 is your TX pin. Okay, and these filters will basically avoid any debounces in the sensor. So let's say sorry, for a brief time, like maybe 1 or 2 seconds, let's say the sensor is sending wrong value. This delay will make sure that is not happening. Okay, so then also we define something called a switch. This switch is basically our GPIO 0. If you remember, we have talked about that. Let me open the diagram. Yeah. So if you see here, we have two inputs, that is your two float sensors and one output, that is GPIO 0. So this switch is the GPIO 0 output. And if you see, I have added it as a output drain. What open drain means is when I turn on the pin, basically it connects the pin to ground. Okay. Now, let's talk about restore mode. So this restore mode basically tells us what should be the position of pin while in the boot. As we discussed while in the boot, we need to basically keep the sensor to high position, that is not ground. Correct. So the restored mode always on will make sure that we connect the uh, pin to the high position. So this is the switch component, which is output, and then binary sensor is the input. Okay. Now we are creating a template sensor. This template sensor basically what it will do is if the state is true for both the sensor, that means this sensor is on and this sensor is on, basically we need to send the motor on, or else false. So this is where we control both the sensors. And then if the return value is 1 and 0, depends on that, we send a request to the 10 is our motor controller, right? So we send a request to motor controller to turn on the motor switch. If the output is 0, then we will make sure turn off. So this is how we write the script. Few things we need to also consider is like one is this logger baud rate to 0, because like when you have a logger enabled, that will basically enable the UART communication. Since we are using TX pin in our water sensor, we need to basically disable the UART, so that we disable the UART by setting baud rate to 0. And then once the once the boot is complete, so initially if you see here, during the boot we're making sure that GPIO 0 is not connected to ground, right? That we will make sure that by setting restore mode. But once after the boot is complete, we need to actually make the pin to ground. So that's what we are doing here. So if you see here, we are turning off the sensor. When you say turn off, it connects to ground. When you say turn on, it connects to 3 volts. That's how it works. So when you where you are basically making the open drain switch to turn off, that means it connects to ground. So once the boot is complete, on boot will run after the boot is completely happen, and this will tell us like at what stage we should run. Like priority 100 is like still there are boot components initializing, and priority 400 is the major Wi-Fi and all initializes. Priority 600 is exactly when all the pins should initialize. So we are using priority 600. These are different stages in the boot. So we are using priority 600 and making sure we're connecting the GPIO 0 back to ground. Okay, so we have seen the changed parts of the logic. So we need to dump this logic into the board. So I already dumped the logic. So in this board, you can click on edit and paste here, and click on save and install and do wirelessly. It will dump the logic. So once you are online, we can visit the water tank sensor web page. Okay, so I'm on the web page, water tank sensor, and as well as let me open the motor controller website too. So we are on the both the sites. One is 10 is basically our motor controller, and this is basically the sensor. Okay, so if you see here, both the sensors currently are lying down. Basically, the ball is at this position. Basically, that means these sensors are floating on the water. Water is full in the tank. Okay, so basically these sensors are currently in this position. Okay, so they are basically floating position. Okay, now let me show you. Let me change the sensor position. If you see, both the float switches are off state. Let me change their state. So I'm reversing them. So one I have inverted, and second also I have inverted. So if you see, both the float switch are basically now in on position. Okay. And also now, if you see here, when the float switch are turned on, the motor also turned on. The motor control sensor is one now, and it's also sent a HTTP request. So when it send a HTTP request, if you see this particular relay, there is a blue light on relay. That means relay is turned on. Even you can validate this in the motor control. So if you see here, the switch is on now. That means that the relay is on, motor switch is on, and water is filling. So let's change this back to this position. Okay, so both are now in reverse position, both are floating, both the switches are floating. So let's go and see what happened here. So if you see, both are now off, and it will take 1 minute to check whether these sensors are off or not. So if you see now, this is also off, and the request is also sent telling motor off. And if you go back to this page, the motor is off, and then the light on the relay is also on. Okay, so this is how the whole setup will work. So in the next video, we will arrange everything in the actual water tank, and also move this back to the switchboard, and set this at the tank side, and everything I will show you in the next video. I will attach link for the code as well as the 3D printing files for the module. So you can go to the description and download them if you want. And please subscribe to the channel.